using least common denominator to simplify equations. Here's an equation with a fraction in it. 1/2 n minus 6 is equal to 10. And of course, by now you know what to do with these. We need to get n by itself on one side of the equation. The first thing we do is add 6 to both sides of that equation, and minus 6 plus 6 creates a 0. Minus 10 plus 6 is minus 4. Now we have 1/2 n is equal to minus 4. We need to get 1n in order to solve the equation. What we need to do at this point is multiply the 1/2 by something that will make it a 1. We remember that the definition of reciprocal is a number that when multiplied by a fraction gives 1. So in this case, if I multiply 1/2 by 2 over 1, I get 1. If I multiply minus 4 over 1 by 2 over 1, I get minus 8, and I've solved that equation, and I know now that n is equal to minus 8. Let's solve this equation, which is a little more complicated than the first one, and then check it. 7/8 of x minus 3/4 is equal to 5/6. Immediately I see here that I have 3 different denominators. I'm going to have to do some work because in order to ultimately do this, I may have to find a common denominator. The first thing I'd like to do is get x by itself on one side of that equation. I add 3/4 to both sides of the equation. Minus 3/4 plus 3/4 goes away, leaving me with a 0. I'm left with this then. 7/8 of x is equal to 5/6 plus 3/4. It seems logical then to work on the expression on the right-hand side of the equation to combine 5/6 and 3/4. I can't just add 5 plus 3 is 8 because they represent different numbers of pieces. One is 6, the other is quarters. I need to find a common denominator or a least common denominator, whatever you prefer. We can see here if we start looking, if I start multiplying 6, 12, and so forth, and then 4, 8, 12, I find right away that a least common denominator is 12. Therefore, I can multiply the 5/6 by 2 in the numerator and denominator, and the 3/4 by 3 in the numerator and denominator. Notice again that I'm not changing the value of the fractions because I'm multiplying each of those fractions by 1. So their value stays the same, but now I have 10/12 and 9/12, and I can add those two together to get 19/12. I've simplified the equation now to the point where I have 7/8 of x is equal to 19/12. I multiply by the reciprocal on both of 7/8 on both sides. 8/7 times 7/8 gives me 1, and I know how to multiply. When I do that, I get x is 19/12 times 8/7. I see right away, though, it's possible for me to simplify a little bit because if I look in numerator and denominator for common factors when I have two fractions multiplied together. Now, it's important you realize that they be multiplied. This doesn't work. This operation of canceling numerators, common factors in numerators and denominators only works for multiplication. It does not work if there was a plus sign or a minus sign in there. Bearing that in mind, we see it's a multiplication. Let's keep going. So I see here there is a common factor of 4 between the 8 in the numerator and the 12 in the denominator on the bottom. I'll take that factor of 4 out, leaving me with a 2 on the top and a 3 on the bottom. I've simplified my multiplication a little bit. I continue and get 38/21. I see that that is an improper fraction, and I can simplify it and get 1 and 17/21. When you're finished, it always is important to look carefully at your final answer and ask yourself, are any fractions in that final result not reduced to lowest terms? Are there any common factors in numerator and denominator that will divide out? When I look at 17, I try to think of what factors might be in that, and in fact 17 is a prime number. There are no factors that I can multiply that are whole numbers together to give me 17. I'm done. That's the answer, 1 and 17/21 to that equation. Let's check this now. How do we check? We put the answer we get back in for the variable, and we see if what we have on the left equals what we have on the right. Does that equality still hold? I say it will be easier in this case to use the improper fraction form of the result to see what happens. I have 7/8 times our supposed answer, 38/21, expressed as an improper fraction, minus 3/4, and I'd like to know if that's going to equal 5/6. I set this up. Then again, it will make it a little bit easier for me if I look for common factors. I see I have a 7 and a 21, and there's a factor of 7 in the 21. I divide 7 by 7, leaving me with a 1, and I divide 21 by 7, leaving me with a 3. Then I check on, is there a common factor in 38 and 8. I see there might be a common factor of 2. I divide a 2 out of the 38 and get 19. I divide a 2 from the 8 and get 4. I've simplified this quite a bit. Now 1 times 19 is 19 in the numerator. 4 times 3 is 12. I can write it this way. I'm not done yet because I now need to subtract 19/12 from 3/4. I need to find a common denominator to do that subtraction. If I multiply numerator and denominator of 3/4 by 3, I'll get a 12 there. If I multiply the numerator and denominator by the fraction on the right by 2, I'll get a 12 there and have a common denominator all the way across. In fact, a least common denominator. 19/12 minus 9/12. 19 minus 9 is 10/12 equal 10/12. The equation holds, and that tells me that I have gotten a correct result for that equation that I just did. It always makes me happy when things work out that way. If you got something different on the left and right hand side, then you would have to go back and start examining carefully all of your steps to make sure what you've done is appropriate and find out where you might have gone wrong with this. Let's look at another method for doing this. It will involve the least common denominator right at the beginning of the problem and will let you simplify the fraction by the equation. It will let you simplify the equation basically by getting rid of the fractions right away. Let's start now with this equation, 7/8 of x minus 3/4 equals 5/6. This is the one we've done before, but let's do it another way that might be a little bit easier. We'll do this. Let's ask ourselves, is there some number that I can multiply both sides of that by that will eliminate all of the denominators entirely? And I start to think about that. I have 8, 4, and 6. What single number can I get from 8, 4, and 6 that I can put in the denominator? And I start thinking about this, and I see that if I multiply 8 times 3, 4 times 6, and 6 times 4, I will get 24 for a common denominator, a least common denominator. But now watch what happens. Instead of making each of those fractions equal to 24, I'm going to do something entirely different. If I multiply both sides of that equation by 24, what will happen is the fractions will go away and I'll have an equation just in integers with the numbers. Watch what happens now. I'm taking that common denominator of 24, which you see goes into 8, it goes into 4, and it goes into 6. And now I'm going to perform this multiplication, doing what I did before, canceling out common terms between the numerator and denominator. Here's how we do it. We multiply, first of all, we have 24 multiplied by the quantity, by the binomial, 7/8 x minus 3/4. Remember, we have the distributive rule, which says that if you have a quantity multiplied by a binomial or a polynomial, that quantity has to multiply each of the terms in the polynomial. You notice I did that. So the 24 is 24 over 1 expressed as a fraction times 7/8 minus 24 over 1 times 3/4. Then on the other side of the equation, I've also multiplied that by a 24, 5/6 times 24 over 1. Watch carefully now. What I'm going to do is look for common factors. For example, if I have 8 over 8 in the denominator of the 7/8, I have a factor of 8 in the 24 too. Here I have, for example, I can divide 8 by 8 to get 1, and the 24 by 8 to get 3. Then I see I have 3 over 1, which is 3, times 7 over 1, which is 7. 3 times 7 is 21x. Notice how slick that was? There's no fraction in that first term anymore because I multiplied it by that common denominator. Let's work on the 3/4. I have 24 over 1 times 3/4. Notice that if I divide 4 by 4, I get 1. If I divide 24 by 4, I get 6. Therefore, I have 6 over 1 times 3 over 1, 6 times 3, 18. There's a negative sign there, it's minus 18. Now let's operate on the right. I see I have a factor of 6 in that denominator, 24 in the numerator. Dividing both of those by 6 gives me 1 in that denominator and 4 in the numerator. Then I have 5 over 1 times 4 over 1. 5 times 4 is 20. What I've done is very slick. I've taken that messy looking equation with those 3 different fractions. Then I've found a common denominator, and it's easiest if you can find a least common denominator, multiplied every term throughout that whole fraction by the common denominator, and transformed a messy looking fraction with a messy looking equation with a bunch of fractions in it into an equation wholly with whole numbers that I know how to solve. I can solve easily without doing a lot of messy math. What I'll do is I'll add 18 to both sides of that equation, get 21x is equal to 38, divide both sides of the equation by 21, and I find that x is equal to 38 21sts. That's an improper fraction. I change it to a proper fraction, and I'm finished. I get exactly the same thing I did when I did this problem previously, but it was a lot easier because when I solved the fraction, I solved it, when I solved that equation, I solved it as an equation in whole numbers. Much easier to deal with. When you solve equations, you clear away the fractions on both sides by multiplying by the least common denominator for the fractions. Let's see if we can do it on this one. 9/10 of the quantity n plus 2 is equal to 1/3 of the quantity 2n minus 3. First thing we need to do is look for a least common denominator. When I start thinking about this, what kinds of things can I multiply the 10 and the 3 by until I get something that's the same? I think and think and think, and finally wind up with 30. That's the best I can do. Then, if I multiply the left-hand side and the right-hand side by 30, or expressed as a fraction, 30 over 1, I express it this way. Again, notice that 30 divided by 10 gives me a 3, and on this side, 30 divided by 3 gives me a 10. And what I have in the denominator is a 1. I've changed this now. I've gotten rid of everything in the denominator, or at any rate changed everything in those denominators to 1. Now I have this, which is an equivalent equation only in whole numbers. 3 times 9 is 27, and then I have a 10 over on the right. Remember that we need to distribute the 27 over the quantity n plus 2, and so I multiply that out, and now I've taken a couple of steps. What I need to do is get n by itself on one side of the equation and all the numbers by themselves on the other side of the equation. I notice that if on the right I were to subtract a 20n, that would get rid of the n's on the right. I notice on the left, if I subtracted a 54, that would get rid of all the numbers on the left. That's what I want to do. Effectively, I add minus 20n minus 54 to both sides of that equation. Adding the 54 gets rid of the 54 on the left. Adding the minus 20n gets rid of the 20n on the right. 2 steps all at once. When you practice, you'll be able to get there and do this. You could do it as a single step if you wanted. What I'm left with is 7n equals minus 84. Then when I solve for this, n is equal to minus 84/7, or n is equal to minus 12. We can check this. How do we do it? We put in minus 12 for n and see if what we have is still an equation when we work that out. I put in the minus 12 and do the math there. And on the left-hand side, I get 9/10 times minus 10 over 1. And on the right side, I get minus 27 over 3. When I work this out, I get minus 9 equals minus 9, so that I'm pretty sure at this point I've done this correctly. Good. Now that we've seen how to do the purely mathematical part of this, let's work on translating sentences into equations that may involve fractions. Since we know how to solve the fractions, now let's look at translating them so that we can set up problems that will use everything we've learned up to this point. Just to review, we have English and we have math speak. If you see the sum of in math, that's a plus. If you see split into, divided. 2 less than something, you subtract. Is the same as indicates equal. And 1/2 of, and the point here is if you see an of, that means multiplication. Let's do some translating. 3/5 of n is the same as 8 less than n. Let's translate this into an equation. 3/5 of n, 3/5 times n, is the same as, equals, 8 less than n, n minus 8. We now have the equation 3/5 n equals n minus 8. Let's work on solving this equation. The first thing I do is I subtract an n from both sides of the equation. If I subtract an n from the right, notice I have n minus n. That gets rid of the n's on the right. Then I have 3/5 n minus 1n on the left. let me write that as a fraction, 3/5 n minus 1. 1 is 5 over 5. I do that because I have 3/5. I might as well put in something equivalent to 1 with the same denominator, is equal to 8. 3 minus 5 is minus 2/5 n is equal to minus 8. Let me multiply that by minus 5/2, the reciprocal of 2/5, giving me an n on the left, is equal to 8 times 5 is 40 over 2, n is equal to 20. I'm finished. Let's try another one. 3/4 of the difference between p and 4 is equal to 4/5 of p. 3/4 of the difference between p and 4. 3/4 of the difference between p and 4, p minus 4, whenever you see difference, that should trigger a minus in your head, is equal to 4/5 of p. Here's our equation. 3/4 times the quantity p minus 4 is equal to 4/5 p. We'll write this out, and now let's look for a common denominator between 4 and 5. The least common denominator is 20. We'll multiply both sides of that equation by 20. We see we have 20 over on the top in the numerator, 4 in the denominator. There's a common factor of 4 there. I can divide that 4 out, which leaves me with a 5 times 3 as the factor on the left. Doing the same thing, 20 divided by 5 is 4, and now 4 times 4 is 16. I translated this, changed it into the equation. 15 times the quantity p minus 4 is equal to 16p. Multiplying the 15 by the p and the 4 gives me 15p minus 60 is equal to 16p. If I subtract 15p from both sides of the equation, I get that p is equal to minus 60, or if you want to put it the way it normally is with the variable on the left, I've solved this for p. P is equal to minus 60. Here's another one. And this one involves square roots. And I want you to pay attention to where the commas are, because that's important when you're trying to analyze these. You see we have the square root of z, which indicates that you're only talking about the square root of z, comma, reduced by 2, which means the square root of z is 1 unit, then you reduce that by 2. Let's see how this is going to work. The square root of z, then the comma means that there's no z minus 2 in there. It's the square root of z reduced by 2 is the same as 1/8. Now I can continue. I have an equation. The square root of z minus 2 equals 1/8. What I would like to do is get the square root of z by itself on one side of that equation. I add 2 to both sides of it. The square root of z is equal to 2 plus 1/8, or 2 and 1/8. When I have this, and I notice I have a square root of z, I need to multiply both sides by itself. And it's easier to do this if I change that 2 and 1/8 to an improper fraction. I'm going to do that. Then I'm going to square both sides in order to get z. Remember that the square root of z times the square root of z is equal to z. I'm squaring both sides of that equation. The square of the square root is the thing itself, and I get then that z is equal to 17 squared over 8 squared, or 289/64. Let me now change that to a mixed number, and I finally get the result that z is equal to 433/64. And again, I want to point out the difference between the square root of z reduced by 2. Notice where the comma is there. And here, the square root of z reduced by 2. One is the square root of z reduced by 2. The other is the square root of z reduced by 2. It's rather important that you pay attention to this because you don't necessarily get the same answer. Z was 16. For example, if we have Z equals 16, then the square root of Z minus 2 is 4 minus 2, or 2. On the other hand, if Z is 16, we get 16 minus 2 under the square root, which is the square root of 14. That's not a nice even number. 14 isn't a perfect square, and it turns out to be, close to 4, and it doesn't really matter what it is. You need to take care when you're looking at these two things so that you get the same thing. Let me make the point again about how commas make a difference on how these things are translated. Notice there's no comma here. 3/4 of n increased by 12 is the same as 7/8 of n. Here we have 3/4 of n increased by 12. The quantity is the same as 7/8 of n. That gives us the equation 3/4 n, the quantity n plus 12 is equal to 7/8 of n. Let's look at this just slightly differently. 3/4 of n comma increased by 12 is the same as 7/8 of n. 3/4 of n, the unit, increased by 12 is equal to 7/8 of n. That gives us this equation, which leads to a result that's quite different from the first.